0.065. Second, EE, 24. Divide 6.022. Second, EE, 23. I got 6.06. Now, why did I round to 6.06 and stop? That's right. This is what I use. I only use my starting data. This was the number given to me in the question. It has how many significant digits? So that's why I rounded to 3 significant digits. And I write mole on my answer. And I'm done. Questions? Everybody feel good about that one now? We're going to do another one. All right, so the next one. All right, we have 15.42 grams. All right, so 15.42 grams. What unit's on top? What's on top?
Oh, grams.
So where are we putting down here?
Grams.
Okay, from a gram, what are we going to? Did they ask me for moles or did they ask me for something else? They asked me for what? Ask for moles. So do I need to go a third step or can I stop? I can stop. I don't need to go a third step because they asked me for moles, so I'm done. All right, so when I cruise over here, which one of these do I want? Okay, what's beside moles? So right here beside moles, I'm going to write 1. All right, come back over here. What's beside grams? So I'm going to put in atomic mass beside grams, but I don't know what atomic mass. So back to my question. So I have nickel, right? So cruise to your periodic table, find nickel. You have what? So 58.69. Now, 15.42 divide 58.69, 0.2627 moles. Questions? All right.
It's going to be 1/3 mole.
It's
always going to be 1/3 mole.
Until we learn to balance equations? Yes. Yes, ma'am.
So I think last night on our homework, when we were given atoms, we were supposed to change it to moles. It was already like it is, the 6.0, whatever. So would you do the exact same thing and it would just equal 1 mole? Or
If you were given 6.022 times 10 to the 23rd?
Yeah.
Anybody else? All right, so for the third one, how do we do on average mass while watching the video? Huh? That one was easy. So we were okay on taking the mass that's given times percent and adding up mass times percent and doing that for the number of times you had the isotope and dividing by 100. So that one we were okay with?
Yes.
Okay. So how many isotopes do we have in this question? 2. So we only need 2 parentheses, right? So we have 56.98 times 81.5 plus 61.58 times 19.5. Usually the biggest issue people have with this problem is what? What do you think?
calculator?
It's a calculator error. All
Do
right.
you always divide by 100 or is it for each like little parenthesis?
It's always by 100. What did y'all get?
58.4.
All right. Typically for significant digits here, the thing I tell people is take it out the same mass. So 58.44. If you want, you can round it up to 58.45 so that you have the same math numbers. I know a lot of you round up because you were trained right in math class, but either one would be correct. Questions about that? So we're okay with average mass. It's just the mole thing that's bothering us.
What do we like? What is the unit on that?
Okay, the units on this, did I not talk about in the video? Because I can't remember. Okay, the units on this are atomic mass units. That's the name of it. And we abbreviate it AMU. Okay? So we write AMU behind it. Now, scientists, for some odd reason, decided that was too long, and they abbreviated AMU. Or you can write U, which is the abbreviation for AMU. Okay? So you could use either one. I know it's odd. All right? So you can write AMU, or you can write U. I will take either one. Okay? You will see both.
So what if we don't?
Happens a lot. Graded physical science labs last night. Data table with 18 slots. I had people who lost 18 points. Dang. I will not forget. Anything else on the opening? All right. Should we tackle homework? Okay. Find your homework sheet. Who was not here yesterday needs one? Anybody? Lewis? Leave it on.
Was it the HB?
One of their HB on them.
Is that okay?
All right, so if we look at question number 1, 1B should be 27 grams. Now, you could have written it at 27.0. You could write 26.9, somewhere in that ballpark. Do you have to have the exact same number I have? No, okay? Yours should be close with 3 significant digits. 2B, I have 29.5. You might have 29.4. As long as you have 3 significant digits and are very close, that's correct. And the unit is grams. 3B, 0.5. So to make 3 significant digits, I made it 0.500. Now, if you had 0.499, that's the same answer. Everybody get the gist of that? Does not have to be identical as long as it's close. 0.5. Number 4B, 0.5 again. This one needs 4 significant digits, so 0.5000. 5B, 4.068 times 10 to the 24th atoms. 6B, 6.05 grams. 7B, 1.50 times 10 to the 23rd atoms. And 8B, you had to solve 2 problems. And when you did, you would find that fluorine has the greater number of atoms. But you had to draw 2 charts to figure that out. Questions? Which ones do I need to do? All right. And number 2, you have 4.25 moles of lithium. All right, 4.25 moles. And you're going to grams. Anytime it says mass, it's grams. All right, so what goes on the bottom? All right, what are we putting on top? So, what number goes beside moles? Did everybody hear what Almaja said a minute ago? Ask your question again. And what was the answer? Yes, until we learn to do what? Balance equations. We're probably a weekish away from learning how to balance. No, it'd be more than that because we got to learn how to name compounds and do some more math. So about a week and a half away from learning how to balance equations. So moles are going to be 1 for y'all until we learn how to balance equations. So every time y'all do moles, it's a 1 until we learn how to balance. Okay? After we learn how to balance, we'll learn how to change the mole from a 1. Okay? So that should answer that question for everybody. Now, grams. Where do grams always come from? What's that, Anthony? Say that a little louder.
The periodic table.
The periodic table. Every time you have a gram, it has to come from the periodic table. So, what was the element in the question? Lithium. So, when we look up lithium, its mass is what? Okay. 6.94 is plenty. You don't have to write down every number on the periodic table. Okay. So, 4.25 times 6.94. Whoops. I got 29 because I punched that in wrong. 4.25 times 6.94. 29.4 will be fine because I only need 3 significant digits. I could have rounded it up, but I just didn't. Okay? Now, my unit is going to be grams. All right, next one. 3. All right. 3 says 11.5 grams of Na. All right. What goes on the bottom? What unit's on top? So grams goes on the bottom. All right. Mole. If it asks for moles, we're done. If it wants atoms, we got to keep going. Now, is this the one that says how many moles of atoms? Scratch out of atoms. When it says how many moles, it just wants moles. Okay? So 3 and 4 probably said the same thing. How many moles of atoms?
Yeah,
It just wants moles. So scratch out the words of atoms if it bothers you. Okay? But it just wants moles. Okay? So, what am I putting next to moles? All right? And where do grams come from? Na. So what's Na's mass? 22.99. All right? So 11.5 divide 22.9.502. Okay? And I called out 0.500. 0.502 is the same answer. All right? Next. 4. All right? 4 has 3.011 times 10 to the something to the 23rd atoms. Okay, what goes on the bottom? Okay, what's it asking us to go to? Moles. Okay, so from an atom, I'm going to a mole. Do I need to go any further? No. So what goes beside moles? What goes next to atoms? When we divide that, I can tell that's 0.5 there. We get 0, 0, 0 to fill in to get 4 significant digits. I can do that one in my head. All right. Next. Number 7. All right. Number 7 has 8.02 grams. Can I turn the page? All right. 8.02 grams, and I think it was sulfur. Yep. All right. So what goes on the bottom? What do we go to from a gram? Moles. Okay. You got to have, let me tell you this. When you draw a chart, can you leave moles out? Can't all year long. Okay, the whole semester you're with me. If you draw a chart other than your King Henry died, you have to have moles in it. Okay, so if you draw a chart and you go grams to atoms and there's no mole in it, you drew it wrong. Everybody hear me say that? Got to have moles. So from a gram, you got to go to moles. So we needed what? Okay, so this is where I was talking about yesterday. You just draw another little section. Okay, the charts are going to grow this semester. They're not going to be just 2-section T-charts. They're going to have more than one section. These are going to grow to 4 and 5 sections long this semester. That's the beauty in a T-chart. The idea behind them is unit cancellation. Those of you who aspire to go to AP Biology or AP Environmental Science will use the same thing when you get there, okay? Some of those courses don't even let you use a calculator on the exam. So this lets you cancel your units so you can multiply and divide, but yet cancel your units. So we got grams, we got moles. You want atoms. So these units are gone. You got moles. Where do you need moles to go in the chart so it'll cancel out? The bottom. All right. So if moles is at the bottom, what unit goes on top? Okay. Now, moles are gone. You're left with what you want. Now you have to do fill in your numbers. What unit did Almagia tell you always goes with moles? Boom, boom. What number goes with atoms? And what did Antoine tell us? Always goes with grams. Periodic table. So what did we say we had for the periodic table? S, or sulfur. So what mass is sulfur? And eventually I will tell you what those are, but it'll be multiple weeks because right now you need to learn where they are on the periodic table and find them. And no, I do not have the entire periodic table memorized before anybody asks me that. I know probably 75% of it. I am not a walking encyclopedia. Okay. What else? Huh? Oh, how did I do it? Yes. You can do it either way, Devonta. You can divide first and then multiply. I don't. I prefer to multiply these two and then I divide by the one that's on the bottom. Okay? That's the way I do it. But if you prefer to divide first and then multiply, it'll still give you the same answer.
I thought I had it backwards. I guess it's 1.50.
No, it's fine. You can round to 1.51. Okay? And as we move further through the course, we'll have to start adding things and our answers will deviate even further apart. All right.
Does it matter, like, if you round and then multiply, like instead of just multiplying on top and dividing by the bottom?
No.
Change it?
No, that's why I tell you there's leeway in these answers. And that's why I also require y'all to show work because these are going to vary. Eventually, this is not going to be an element. It's going to be a compound. And y'all are going to have to add up the masses of the compound. And some of y'all are going to figure out, I don't want to write down that whole mass on the periodic table and round the whole numbers. And as y'all start rounding here, and then you start rounding when you add up these compounds, this is going to vary more. Okay? So I'm not going to hold you to an exact answer. Significant digits are going to matter. Units are going to matter. Show me your work. I can follow the steps as long as you show me the work. Okay? That's why the next test is half multiple choice, half free response. The two tests after that are entirely free response. I'm not interested in can you guess and give me the right answer. I'm interested in can you demonstrate the work. Okay? So no work, no credit. All right, Chris, you said number 5? All right, so number 5 has 6.755 moles, and we're going to atoms. 6.755 moles. What goes on the bottom, Chris? What do we put on top? Yep, what goes beside a mole?
1.
Beside atom?
6.022.
So what exactly do you need me for? I don't think you need me either. Because that's right. Exactly. So 6.755 times 6.022 second EE 23. I got 4.06. 7 times 10 to the 24th. All right. Does that help with homework?
Could you do it differently, like from atoms to moles? From moles to grams?
Yeah.
For that one?
For that one? No. Because I gave it moles.
Or I got 4.068.
I don't know. Let me see what you did. Just bring me the paper.
Never mind. No. That was stupid. No one.
Anybody else? Question? All right. So are we ready for yesterday's quiz that we didn't give?
No.
What's wrong with yesterday? Well, then make it up since you weren't here the day before when I taught it. You just got to make it up. All right. What about the rest of y'all? Did you check your homework answers? I posted them on the website. Now, those of you who haven't signed up for Remind, I sent a remind last night to let you know those answers are posted on the website. They were also, or should have been in the video yesterday. Were they in the video?
Were these not?
No, the back of them were not, but they're not on the quiz today. The quiz today is on the homework from yesterday. So the atomic structure homework and the ion homework. Those are the two that were on the website. How to find protons, neutrons, and electrons. Atomic number, atomic mass.
That's what the quiz was on?
Yes, not on the stuff from yesterday while I was not here would not be on a quiz today. Even I'm not that heartless. The quiz today is on the stuff I taught when I was here. Good Lord. Not quizzing you on stuff I didn't teach but by video. Now, you need a periodic table. I'm not going to ask you protons, neutrons, and electrons without one. Okay. Look. Isotopes mean you have the same number of protons, but different numbers of neutrons. Or they have the same atomic number, but they have different atomic mass. So, like the examples I gave you were, we talking about graphite, carbon 12, they have the mass of 12, but then radioactive carbon-dating has a mass of 14. So the neutrons would be different, but the masses of 12 and 14 could be different. But when you look at carbon, carbon is always going to have the same atomic number of 6. So that can't change. They all have a proton or atomic number of 6. Go on. Anybody else? All right, need a periodic table. I unbury it out of this stack of crap. It's in here somewhere. Maybe I should punch holes while y'all do the quiz. Ah, there it is. I can do it. I'm just slow. Alex, are you here? If it is close, no, I'm not going to take off. If all it has right is the first letter and the word is not recognizable, I will not give you credit. It has to be in the ballpark or pretty close. Leave it at that. All right, who's still working? Anybody? So I got 3 hands. All right. All right, how about now? Again, everybody enough time now? All right, mashed potatoes to the front. All right, if you will, find your homework sheet from last night. We're going to do 5 to practice. I'm going to give you not that long. At most until 9:25. At most, probably not that long. Because I'm going to start some naming today. All right, let's see. Let's do one more. Wait up. Let's do 2C. Let's do 3C. 4C. Let's do 6C and 7C. That's 5 questions. Now, when you finish, or if you want to check, here are the answers. If you get stuck, then I want you to ask. You can do it on anything you want. I'm not checking this. I'm not collecting it. This is for who? That's for y'all. Because what did I tell you? You have a quiz tomorrow. All right? And I don't like to grade F's. It's depressing. I got enough F's 4th period to last me the rest of my life. Oh, yeah. I can tell you the answer back of that. Hang on 1 second. I'll set these down. And I'll be glad to. All right. So on the back side of your paper you did yesterday on average atomic mass, you find them and I'll tell you the answers. Average atomic mass. Average mass would be number 1. Would have an answer of 69.74. Number 2, 63.61. Might have rounded to 62. 63.62 maybe. Number 3, 32.09. Number 4, 103.41. And number 5, 41.28. Or you might have rounded it to 41.29. If you didn't hear it, they're right here if you need to come look. Generally speaking, I'm not going to get bent out of shape about significant digits on that one. Okay. For the most part, yeah. The biggest thing I'm looking for there is to make sure you did it right. And if you round off to like 2 significant digits, I'm not going to be able to tell if you did the problem right. Because you've rounded off so far, I don't know if any of the places behind your desk were right, and I'm not going to know if you actually did the question right. So you're either going to have to show me your work to know if you did it right or something. So for the most part, I don't check significant digits in that one, as long as you have the right unit on it and the work's right.
Oh, so you meant A and U?
A and U on all of those, yeah. And if you get stuck, don't know what you're doing, yell for me. I'm just punching holes in papers. Given I have no planning period, I got to maximize my time where I can. Question, Lewis? Question? You need a computer to watch how to do it? Yeah? All right. I'm going to get my keys and you can unlock the cabinet. You got earbuds or you just going to listen without them? Here, here's the key. Yeah, Alex. You need a periodic table? Here. I know Lewis is going to need one too. Oh, Lewis's desk. Is anybody else not here the day I handed out periodic tables and didn't get one?
Will you count off if we don't have units within the table?
Put it this way, you will not get much partial credit if you don't put the units in the periodic or in your T-chart. So you want to give me as much information as you can, because if you make a small mistake, like a calculator mistake, if all the stuff is in your chart, for example, when we're on the quiz, there are 20-point questions. If it's a calculator error, it's -2, if all your information is in the chart. But if your information is not fully in the chart and it's a calculator error, I'm not going to give you -2 because stuff's missing in the table. So you want to give me all of that information. Anybody else have a question? I can punch holes later if you have questions. I'm not doing anything I can't stop. If you get one done and you want to check before you keep going, the answers are right here in front of me. Come check them. You know what I forgot to do today? I forgot to check SMOB. Everybody in SMOB? I hate to have send somebody now. I feel like an idiot.
If I don't put the leave the 0 there, we can mark it off.
No, I will not, because that 0 is not significant, so it does not matter. Right there. So you're doing number 2, so it would be up here.
Oh, yes.
What'd you do? That looks like a calculator error to me, because my best guess is you left the decimal out of 1.38 and you wrote 138.
Yes, I did.
Gotta hate when you do that stupid stuff. When you set the whole problem up right and leave a decimal out. Yes. Those significant digits will go away somewhere around week 12-ish, once I know everybody's got them. Because significant digits will not be on the exam. So eventually I'll cut you a break, but it'll be a while. So what?
They won't, like, how are they not?
It's not part of the curriculum. Y'all are just in an honors class, so it's one of the extras that you get from being in the honors class. Lolly is really squinting her eyes at me bad right now. So she's either having allergies or she's getting really annoyed. It's all part of that extra weight. Yes, my dear.
So,
Uh-huh.
oh, because it's 3.
It's 3, so you need 3 there and you have 4.
What do I want?
Right through here, so that's 2, and that's 2C, so that would be 2C, and then 3C, and so forth and so on. Because you didn't use nitrogen would be my best guess. That's not nitrogen's mass, that's somebody else's mass.
Oh.
I don't know whose mass. Looks like aluminum.
What did I do? What?
You, looks like you combine 2
Oh,
different questions. Did you get it, Jada?
I multiplied. Yeah,
Looks like you combined 2 questions.
right.
What about the next one?
Yeah, I don't think I did that one right either.
All right, so you got 1.38, but that, and you set the chart up right. You just have the wrong mass. So you've looked up the wrong element. And that one, you've set it up right. And I don't know who's mass. You've got sodium's mass. You're doing the mass for B. You're doing the mass for I don't know who. That's B's mass. I don't know whose mass that is. That's like A's mass. I think you went back and picked up question 1, B's mass.
Okay. Whoops.
Okay. We'll find the right masses of the elements that are in the question. Remember, you don't have to wait to check to the end. If you want to check before you get there, make sure you're doing stuff right. Along there. See, it helps when you got the right element.
Yeah. I don't know what's going on.
Yes, ma'am.
Yeah.
So right here, we're supposed to do, what is it? 4C? No.
Uh-huh.
Yeah, 4C.
Mm-hmm.
It's up here. Okay. Is there a reason why they put NE?
No, it wraps around the next line. So you're going up. It should wrap around on the next line. So it's atoms of zinc.
Oh, yeah.
Okay, so see how you put your 1 mole there? Where should that
That's
number
supposed to
be?
be down here.
Yes.
Okay, but like, I know they put that for grams so you could see what the atomic mass is.
Right.
Why would they put it for?
You don't need it. It's just extra information for you because you don't have grams in your charts. You just don't need it.
Okay.
Okay? What's wrong, Ollie? You don't want me to lose your paper? You want me to look at your paper? It's okay if I look. It's not like I'm looking at something, I can't see. Apparently it was. You left. You didn't let me see it. Oh.
What did I do wrong here? For 3C.
Off the top of my head, I'm going to guess you copied the question down wrong. It's 5.87 grams and not 58.7 grams. Go see if that's it. Was it right? Yep.
This one you said you multiplied by the top, then divided.
So you'd multiply by 1 and divide by that.
Yes.
Oh, that one? I would multiply this by that and then divide by that. But you don't have to. You can divide first and then multiply by 35.45 if that's the way you see it and that's your preference. Okay? I tend to multiply and then divide.
I do got a question.
Yeah.
So you said like it's got the grams, it's got the little element after.
Mm-hmm.
You have to put the element in between.
You can just put the grams and I won't take off. You do not have to write the element. Eventually, the element will be important. It is not important currently. Golly, you'll be looking at something. You're getting them right. They pay me to answer questions. It's hard to imagine that I make over $5,000 a month just to answer questions. Don't get excited. They tax it heavily and I pay insurance, and by the time all that's done, I only bring home $2,700 a month. Dang. Then I got to pay bills, and I'm poor as a church mouse. And what little I have left, my children take. The lesson in that is don't have children. You'll be a lot wealthier.
I have a question for
Yes.
4C. I was looking at it.
Bye, dog.
The 2.25.
Bye, dog. Oh crap, I forgot to call the vet. Hold on, I gotta call the vet. Put his cat in the crate this morning to bring. Glad I said that. Dang.
I either got one of these two hands. Oh, I'm gonna do that. Well, what you
Wait.
for?
This is free. This is free.
I'm gonna stand that long way down.
I like how you just say, I'll let it. My cat's terrified. He used to be everywhere, and if you look in my room, yeah, and you see me in my chair, I just turn my head and see your ghost. You know, I get that Snapchat feature. And he goes back up there and I'm like, you know what? You tell him to come back in. So he comes back there. I'm just saying, if your cat's gonna get up, you set the time for one gram. I'm not gonna worry about that. When he comes out late night, I watch things like that.
I just woke up. There's a baby on. Yes, I was. But I didn't even realize it was bleeding, so I looked at the kitchen and I was blood all over the floor. I didn't feel it until I saw it. You know how that happens? Yeah, I'm gonna be really tired. Yeah. I remember when it was winter, the bathroom floor was really cold.
All right, well, thanks. All right, bye-bye.
And I didn't feel it until I got in the shower and the hot water and I was down and
Glad I said that's double. All right. How are we coming?
Halfway.
Because we're at 9:26. So at 9:30, I'm going to cut you off.
What is it?
That's the 37. Yeah, I was calculated wrong. I scratched out their answer. It wasn't right.
Oh, we have to put, after we put grams, we have to put the thing too.
If you don't write the element, I will not mark it wrong. As long as you have the grams or the moles, then you're fine. Okay? But you have to have either grams, moles, atoms.
Okay.
Do we have to start doing it eventually?
Eventually, it will be important to have it in the chart. You will never be required to write it on the answer, but it will be important to have it in the chart because they will start changing.
Wait, where's the answer?
For which one?
60?
Huh?
60.
It'll be at the end. It'll be after the equals.
Wait, that's the answer.
Yeah.
I got 265.
2.65 times 10 to the negative 10.
Because, okay, so I got this. This was the atoms, and I changed it to moles, and I put that atoms on the bottom. And then I got this.
You want C?
Uh-huh.
Which one?
This one.
That says 12. So that's 12.
Yeah.
That's 23. And that's that. It's not punched in the right. Go to your calculator.
This one says 27.3.
Yeah, that's 37.3.
27.
37.4 is the same answer.
You just rounded.
I I just round it different. We're not all going to agree all the time, Angel. It's okay. It's A-okay. All right, who's somebody who's done?
I'm done.
Bring me your local hands here so you can hand out a chart for me. Okay. You divide them up for all I care. Since I got 3 people standing there. All right. If you did not, check your answers. I'm going to call them out real quick. Okay. Question 2C. Should have been 19.3 grams. 3C should have been 0.1. I put 00 behind it in the answer key. 4C should have been 37.3 moles. Thank you, my dear. 37.3 moles. 6C should have been 2.65 times 10 to the negative 10th grams. And 7C, 2.31 times 10 to the 22nd atoms. Number 7, you would have 1.50 on top. The mass is 39.1 grams on the bottom, 1 mole on the top, 1 mole on the bottom, and 6.00 times 10 to the 23rd on the top. And then the rest is the calculator. Punch it in again. Because Anthony's nodding. Punch it in the calculator. 1.50 on the top, grams on the bottom, right? The 39.1 for K. 1 mole on the top, 1 mole, and then 6.022 times 10 to the 23rd.
You said the answer was what?
2.31 times 10 to the 22nd.
Okay, I'm gonna say this.
Okay, so that would be a -2 mistake tomorrow because you have all the work and then just a calculator error. All right. What? 2. Providing you have a unit on your answer. Otherwise, it'd be a -1 also because you don't have a unit. All right. Now, with our remaining 25 minutes, we're going to start talking naming. Okay? Now, your quiz tomorrow, that's attractive information, is on average atomic mass. Okay? So your quiz tomorrow is on average atomic mass and on mole conversions. Everybody got that? All right. So, today, we're going to talk nomenclature. Now, nomenclature is a Latin word that just means system of naming. It is not unique to chemistry to say nomenclature. Okay? Lots of disciplines have nomenclatures. All right? Biology has a nomenclature. Chemistry has a nomenclature. Lots of other disciplines have nomenclatures. Now, we are going to learn how to name various compounds. Now, before we can get too far into compounds, we have to at least know that there are 2 types of compounds. Okay? We're going to learn to name 2 types of compounds. One is an ionic compound, and 2 is a covalent compound. Most of you will prefer ionic compounds until I teach you covalent compounds, and then you'll be like, oh yeah, I like that system as well. Those prefixes are pretty cool on like covalent. I like those. However, you can only use those prefixes on covalent. And as soon as I teach you those, we're going to jack up ionic compounds because you cannot use them on ionic compounds. And you know what breaks loose in our naming system. Okay? So I hate teaching covalent compounds because once we get on it, and then I go back and teach a small piece of covalent, the world implodes. So how on earth are we going to keep it straight? Well, we have to be able to tell the difference. Now, I'm not going to define ionic and covalent. Some of you might have learned about electrons in middle school, which is fabulous. We're going to do that down the road. Okay? How can we tell the difference using your periodic table today? That's all we're going to do with them. We'll talk about where the electrons go later. So, periodic table. How can we tell the difference between ionic and covalent? Well, can anybody tell me anything about the periodic table?
If one of them, like if the number has the plus or minus number.
We're going to get to that. You're way too advanced for what I want right now. Just looking at the periodic table, can you tell me anything about what you know about the periodic table? There are elements. Can you tell me how they're grouped? Columns are groups. Good. You know anything about them? What kind of elements they are? Metals, metalloids, and okay. Instead of saying gases, how? Because they're not all gases over there. Okay. Everything over here that is yellow and orange are not gases. So what is everything that's yellow and orange called? Because they're not all gases. Nope. All the blue are the metals. All the blue are metals. The green are your metalloids. So what are this yellow and orange called? Because they're not all gases. What? Non-metals. Okay? So leaving the metalloids out of the mix. Metals and non-metals are how we're going to tell ionic and covalent. So what do you think the ionic compounds are? Metals and? All right. So an ionic compound is any combination of metals and non-metals. Okay? Any combination of metals and non-metals. So, what's a covalent compound going to be then? Okay, the metalloids we said we were going to leave out. So leave out the metalloids. So covalent's going to be what? Gases. Okay, leave that term out. No such thing as gases and non-gases. They're either going to be metals or non-metals. Okay, that was ionic. So we got to change it up for covalent. Okay, it's got to be one or the other. Is it metals and metals? Or is it non-metals and non-metals? No. All right. So, covalent is all non-metals. All right. So, the one that's all metals that y'all said will be a metallic bond, and we'll talk about that when we do bonding. Okay? We're not going to learn to name anything that's a metallic bond. It's not our curriculum. Now, somewhere in your 8th grade curriculum, even if it's recessed in your mental files, okay? Even though y'all say you've forgotten, you really haven't. It's there. All right? We do a rough sketch of the periodic table. You know that there is a staircase on the periodic table, right? Everybody knows that. On this staircase is the metalloids. Everybody should remember that, correct?
That's the green things?
That's the green things over there. They're not all what we're going to label, but yeah, we'll get there. Now, over here on the left are the metals. The metals are on the left of the stairs. And that's the way we describe them. Left of the stairs.
I have a question.
Mm-hmm.
So like on the chart, versus there, like uranium,
That's why I said we'll talk about there. When we talk about metalloids, I'm going to tell you, it depends on which periodic table you look at. Not every periodic table labels the same elements as metalloids. Why that is, I have absolutely no idea. There are a couple of them we can't seem to agree on. Like up there, AT is not labeled as a metalloid. On some periodic tables, AT is labeled as a metalloid. PO is labeled as one there. On some, PO is not labeled as a metalloid. The only one I can tell you with absolute certainty everybody agrees on is aluminum. Aluminum is never a metalloid. It's a metal. Okay? Now, the non-metals. Where are the non-metals always at? The non-metals are always at the right. Okay? The non-metals are always on the right. Always. There are no exceptions to that rule. I take that back. There is one exception, which is what I meant to say. What's the one exception to that rule? Hydrogen. Okay? Hydrogen right here is the one exception.
And that's a non-metal.
That is a non-metal. Okay? So, when we look at examples, we should be able to figure out what type of compounds those are. Are they ionic or are they covalent? Because it will make a difference in which systems of naming we can use in a couple days. Okay? Some of them can be named with the stock system and the old system. Some of these can only be named with the stock system. And if you name them with the wrong system, it's wrong. There will be no partial credit with naming. Everybody hear me say that? No partial credit with naming. If you use the wrong symbol, it's wrong. Okay? You have a periodic table. You have a blue chart I'm going to explain to you probably today. But you have two charts you will have access to on the test and the quiz. You can look up every single symbol, every single name. If you write it down wrong, whose fault is that? Yours. Okay? I'm going to pick on Caroline, but she just looked up 2 elements wrong on her periodic table. She got the masses wrong because she got it wrong out of the question, and one she moved the decimal place wrong. Okay? You got to be careful and check behind yourself. Okay? Almija was guilty of it a minute ago when she wrote down 138 instead of 1.38. So, fluorine is an easy one for people to get wrong. What's the symbol for fluorine? F. What do you think people write down all the time? All the time. Or potassium. People are quick to write that one down. What's potassium?
Okay.
What do you think they write a lot of times?
P.
They write P a lot for potassium. Or sulfur. They write S. But then turn around and I ask sodium, and they write what? SO. Okay, instead of Na. They make stupid mistakes because they get in a hurry. Don't do that. As soon as you write it, I just mark it wrong, and whatever the point value is, if it's a 10-point question on a quiz, it's minus 10. Don't get caught in those kind of traps. All right, so 1 through 5 up there. Tell me the type of compound. Do it real quick on your notebook paper so everybody has a chance to do it on their own. It's an ionic or is it covalent? You can write I and C to make it fast. Use your periodic table. Because yes, I would ask something that simple on the test. Also gives you a chance to hunt for the elements if you don't know where they're at. Hey, Miss Kenny, you got me somebody else?
I am.
I don't understand why you don't put them in court.
Vince.
Okay.
And he's gonna be in short period. And I'm trying to get fixed.
Okay.
Okay?
Okay.
Cultures and science. There you go.
Okay. We'll see y'all.
Third period.
Okay.
It's not.
Were you in physical science before, or is this just your first time?
She has not been in school yet.
Okay.
She's probably behind, but there is a class that she's.
Not a problem, I'm just curious where we're at. You're the same, but harder than when she came up.
So there you go. Is that the same way? Yes.
Just asking. That's why I say that joke.
All right.
All right, Jan. So what's that ACL? It's not. All right, CO2. Covalent. K2 SO4. Ionic. HBr. All right, so we got some dissension in the crowd. How do we decide? HBr. All right, did y'all hear what Diamond said?
Yes.
All right, so H is a non-metal and Br is a non-metal. Okay, it's real easy to mess this one up. So H is a non-metal. I wrote C instead of an N for non-metal. Okay, non-metal, non-metal, and that means it is covalent. It's really easy to look up here and go left side of the periodic table, right side of the periodic table, metal, non-metal, and go, oh, that's ionic. That's a non-metal though. That's your one exception. So non-metal is covalent. All right, and Pi3 is covalent. Okay, so we're okay on all of those. All right, so we're going to learn to write names of ionic compounds first. All right, ionic compounds are the easiest ones to name. Now, in order to write the names of ionic compounds, we're going to use two things. We're going to use a cation and an anion. You might remember what those things were? Talked about it the other day, I think, if memory serves. I'm getting old, I might have forgot. What's a cation? I thought we talked about it.
And it loses electrons.
Okay, so a cation is basically a positive ion, and it loses electrons. All right, and an anion is a negative ion, and it means it gains electrons. Now, for our purposes, over the next few days, okay, we don't necessarily have to use the words. We don't necessarily have to understand what it means. Now, if we have something like Ca plus 2, this right here is referred to as an oxidation number. Okay? And we've already said that it tells the number of electrons lost or gained. Most people do not teach this concept the way that I do. I'm teaching it back-asswards. I think I said that wrong. I did. All right, so pretend I didn't say it. In the county, they teach all of the stuff in the periodic table first, so that you know how to find oxidation numbers off the periodic table before you ever teach naming. I don't teach it that way. I do all the math and the interesting stuff first, and then I teach all the droll, boring stuff second. Because if I teach all that other crap first, none of y'all are going to like class. So I don't teach it in that order. I've only met one other person in my entire teaching career that teaches it in the way that I do. So, given you know nothing about the periodic table, I just handed y'all a blue chart. So if y'all look at that, please. Now, this blue chart is a chart of oxidation numbers. Y'all are going to become somewhat dependent on this chart. So under the title, you will notice that it says what? We'll do what? So that means day 60, what happens? You don't got it no more. I'm not gonna take it from you. You can keep it. I don't need it back. They're gonna be wrinkled and ugly by day 60. However, can you use it on any more quizzes, tests, or anything else? Because by day 60, I will have taught you all of those other skills you need to find and use the things on this table. Okay? So you will no longer need these if you've learned the skills to get to day 60. Does that make sense? But right now you don't have those skills. So, if you need to know sodium's oxidation number, what are you going to do? You're going to look up sodium in this column. Now, how does this sheet work? Now, I thought I was rather ingenious a few years ago. Clearly, I need to take a word class because I'm not too smart. So, I take this handy dandy sheet of paper here, and I cover this up. These three columns work together. So, this is the name of the element in alphabetical order. This is the symbol of the element. And these are the oxidation numbers the element has. If I flip it over, these would be the continuation of the elements, the symbols, and the oxidation numbers. Then my ingenious self thought, okay, let's take the paper. So, on the other side, I put the polyatomic ions we're going to work with tomorrow. And I put them here and put their symbols. Then I was like, dang, I missed a couple. Then I figured out, wow, I already put them in the table. I can't go back and re-alphabetize these things. So you'll notice some of them are not alphabetized. Because I forgot them, I just added them to the bottom. So when you're looking for some of the polyatomic ions and you're like, they're not there, Ms. Wall. So look towards the bottom and you'll find some of the ones that are missing because Genius here figured out she couldn't go back and re-alphabetize the column because they were already in the table. All right, on the back side, because tomorrow we're going to talk endings, and Caroline said on the quiz, do I take off for spelling? No, for the most part I don't. But some of y'all are going to have a hard time with spelling, so I put some of the common spellings for binary ions on the back side, because spelling, when you have to change the endings yourself, are difficult. So I put the spellings there so we would know how to spell. For example, when you have to change nitrogen to nitride, some of y'all are not going to know how to do that. So there's the spelling. Oxygen to oxide, there's the spelling. Okay? Now, the elements are on the periodic table that I've provided, as well as on this. So nobody should say, are you taking off for spelling? Look, if you don't know how to spell phosphorus, look it up on the card. Don't spell phosphorus wrong, or yes, I'm going to take off for spelling. Now, there are 4 acids you have to learn. Okay? And that's where I'm going to stop for today. Is the 4 acids you have to learn. So if you'll look here, there are the bottom 4. Okay? Hydrochloric. You can mark them on these. They're your cards. Hydrochloric, sulfuric, nitric, and phosphoric. You can highlight it. You can star them. You can circle them. Some of y'all are out there thinking, oh, this is stupid. I'm going to get used this far on this test. I think I'll learn these 4 acids. Okay. So if I walk over here, pull out the oxidation sheet y'all get to use on the quiz and the test. You get to use mine. Tell me what's missing. He's looking. Those 4 acids are not on the oxidation sheet you get to use on the quiz and the test. They're identical, minus those 4 acids. So, on the first quiz, on naming, you will see one of those 4 acids. And some of y'all will come in here 5 seconds before the test and be, oh my God, I got one of those 4 acids. You will see one of them on the quiz or the test. Now, odds are good based on the weather. It will not be this week. It'll probably be next week. So, you have until next week to know those 4 acids. What is your homework tonight? No, make sure you get past the quiz tomorrow on average mass and mole conversions. Okay? Tomorrow. I said it like 3 times.
I know,
Yeah.
by the time I study, I don't think it.
I haven't even taught you how to name yet. How are you going to have a quiz on naming?
Ionic and covalent names.
Haven't even learned how to name.